I'll create a polished, cohesive script based on common AI research topics. Since your original script was empty, I'll demonstrate the process with a sample script about transformer models, a critical area in AI research. Here's the polished version. Ever wonder how AI systems understand language so remarkably well? The answer lies in a revolutionary architecture that's reshaped the field, the transformer model. Today, we're diving deep into the technical heart of transformers, exploring how they process information, why they outperform their predecessors, and what this means for the future of AI. Before transformers, recurrent neural networks, RNNs, dominated natural language processing. But these models had critical flaws. They struggled with long-range dependencies, suffered from vanishing gradients, and processed text sequentially, which limited their efficiency. Imagine trying to read a book one word at a time while remembering the plot from 100 pages back. That's the challenge RNNs faced. Enter the transformer, introduced in 2017's Attention is All You Need paper. This architecture abandoned recurrence entirely, relying instead on self-attention mechanisms. Let's unpack this. Each token in a sequence interacts with every other token, creating a dynamic representation of context. It's like having a team of specialists, each analyzing different parts of a document while constantly sharing insights. Here's where the math gets interesting. The core of the transformer is the scaled dot product attention mechanism. For any given token, we calculate three vectors: queries, keys, and values. The attention score between two tokens is the dot product of their query and key vectors, scaled by the square root of the key dimension. This score determines how much information from the value vector should be focused on. Multi-head attention takes this further. The model learns multiple sets of queries, keys, and values, allowing it to capture different types of relationships. Think of it as multiple lenses through which the model examines the same information. But wait, how does the model understand word order? Unlike RNNs, transformers don't process text sequentially. The solution? Positional encoding, a mathematical representation of each token's position in the sequence. These encodings use sine and cosine functions of different frequencies, allowing the model to learn relative positions through the transformer's layers. After attention mechanisms, each position goes through a feed-forward network, a simple neural network that processes the information. While seemingly basic, this component allows the model to learn complex transformations. The key innovation is that these networks are applied identically to every position, maintaining parallelization benefits. Transformers are trained using masked language modeling, where the model predicts randomly masked tokens. This self-supervised approach allows them to learn from vast amounts of text without human-labeled data. The result? Models like BERT, GPT, and T5 that can perform tasks from translation to question answering with minimal fine-tuning. The transformer architecture has become the foundation of modern AI. Its ability to capture long-range dependencies, process sequences in parallel, and scale efficiently has enabled breakthroughs in NLP, computer vision, and beyond. As researchers continue to refine these models, exploring efficient variants, improving reasoning capabilities, and addressing limitations, we're witnessing the next era of artificial intelligence. If you're interested in diving deeper into transformer architectures, check out the original paper or explore frameworks like Hugging Face's Transformers Library. Stay curious and keep exploring the fascinating world of AI research. This script maintains technical depth while ensuring accessibility, uses natural speech patterns, and follows a logical flow from problem identification to solution explanation. The content is structured to engage both technical and general audiences, while emphasizing the significance of the topic in AI research.